Hello friends. So in previous video we have seen introduction to hashing, in which basically we have seen different hashing techniques and the collision resolution techniques in the hashing. So in this video we will see basically the example how the collision get resolved by different collision resolution techniques. So out of that, the first technique, which is a separate chaining. So why it is called separate chaining? Because it creates a linked list to slot and new keys inserted into a linked list. Since here the linked list appears like a chain, so that's why it is called as the separate chaining. So now consider example here. So basically in this example, here we have considered the function as key mod 7. This is a hash function, and the keys or the data which you want to insert in the given hash table is 50, 776, 85, 92, 73 and 101. So if you see here practically, let's say I want to insert 50. So 50 mod 7, so it will give me 7 7 ka 49, so the mod answer is 1. So at first index 50 will get inserted. Second, that is a 700, so 700 mod 7, that is 0. So at the 0th index 700 will get inserted here. Like this way, next element is 76. So if I find 76 mod 7, so I'll get here answer as 6. So index 6, the 76 will get inserted. Next is 85. So 85 mod 7. So I'll get answer as 1. But at the first index already 50 is inserted. So here collision occurs. So at the first index itself, it will add the another link and it inserted 85 in that particular link. Next is 92. So if I 92 try to insert here, I'll first of all find out this index using 92 mod 7. So I'll get answer again as 1. So at the first already there was a 50, 85 collision occurs. So it will create a new link and it will add over there after 85, 92. Then there is a 73. So 73 mod 7 will get 3. So at third index 73 will get inserted. After this there is 101. So 101 mod 7 will get here again the 3. So at third index already there was 73. So collision occurs. So that 101 get attached after 73 over here. So since this structure looks like the chain, so that's why it is called as the separate chaining principle. Now let us look at the basically the advantages and disadvantages of the separate chaining method. So here the advantages are, it's simple to implement. Hash table never fills. So as collision occurs, it creates a link and attach the link to particular index. So hash table never fills. It is a less sensitive to the hash function and the load factors. It is used, very important, when it is unknown how many number of keys and how frequently the keys to be inserted and deleted in a given hash table. So very important, when to use basically the separate chaining method is when we are unknown about how many number of keys and what location keys supposed to be inserted. What are the disadvantages of this scheme? The first thing is cache performance is not good, since basically we are using the linear linked list here. Then there is a wastage of space. If chain becomes too long, then search time becomes O of n. So it becomes a linear search time in the terms of n, and it needs extra space for links. So these are the some disadvantages of the separate chaining method. Now let us go for the next method of collision handling. So the next type is open addressing. So open addressing, the keys are stored inside the hash table. So it is also called as a closed hashing. Keys are stored inside the hash table. In previous method we have seen that it creates separate link and get attached with the hash table. So in open addressing, the first technique is linear probing. So why it is called a linear probing? Because when collision occurs, we find out the next location linearly or next bucket linearly to store our keys. So it keep probing until empty bucket does not found. So let us take simple example. So let's say there is a key and hash function is defined as the key mod 7. Now say if the collision occurs, say I get answer as hash function index is 0 and 0th place there was already some keys there. So that means collision occurs. So what it will do, since answer was 0, what I will do, 0 plus 1 mod table size. So again I'll rehash the function. Again let's say it gives the index 1 and at first index again there is a collision. So again it will add 0 plus 2. So it will continue till we are not getting the empty slot. So here we will find modulus of table size. So here that will be hash function mod table size will be there. So now let us look at the example of linear probing. So here consider basically here table size is 10 and these are the keys I want to insert. So first of all I want to insert 50. Hash function is key mod table size. Table size is 10. So always remember hash index goes from 0 to further whatever the table size is. So 50 mod 10 is 0. So at 0th index 50 gets stored here. Next is 700. Now 700 is basically 700 mod 10 is 0, but a collision occurs here. So what we'll do now, here the next index location will find out by initial hash value is 0 plus 1 mod 10 is 1. So next index is 1. So at first index we store the 700. Actually the 700 belongs to the 0th index, but since it is stored at the first value, we are giving here a chain. Next is 75. So 75 mod 10 is 5. So at fifth location we are storing 75. Next is 85. So 85 mod 10 is again 5, but 5 there is already a data, so I'll find the next location. So 5 plus 1 mod 10, 6 mod 10 is 6. So at 6th location we are storing here 85. Next is 92. So 92 mod 10 is 2. Second location we are storing here 92. Next 73. 73 mod 10 is 3. So at third index we are storing here 73. 101. So 101 mod 10 is 1, but at first location there is 700. So we'll find out next location. 1 plus 1, that is 2 mod 10 equal to 2. But again 2 there was already certain data. So again what I'll do, since here hash value for 101 is 1, next time I'll add 2. So 2 plus 1, 2 plus 1 is 3. 3 mod 10 is 3. But again at third location there is a 73. Again next time I'll add here 3. So 1 plus 3 mod 10. So that will be 4 mod 10 is 4. So at fourth slot is available and I will insert here 101. Next is 15. So 15 mod 10 is 5, but at fifth location there is 75. So I'll find out next location. So I'll go for rehashing. So hash value is 5 plus 1 is 6. 6 mod 10 is 6. So at sixth location there is 85. So collision occurs. Then again I will add 5 plus 2. Now instead of adding 1 I'll add 2. So 5 plus 2 mod 10, that is 7. So at 7th location it was empty, so we inserted here 15. So now see, look at here, these are the chainings we are giving here. So initially all this is basically the data field, this is the chain field. So here whenever the 50 was there, so 50 is at right place, no need to add. But at the 0th index, the second value we are storing at the index 1. So here we are giving now index 1. Now 92 is at right index, so minus 1. 73 is right index, so no need to give chain. 101, actually 101 is not right index, it is the first element which you have done here for index 1, but it has a different place, but we can't do it at this point. We'll see the next concept after this. Now 75 is at right place with index 5. 85 is at not right place because it's supposed to be at index 5, but now here we'll add a chain so that after 75 the index fifth element is 85 and which is at the location 6. So that 6 we are adding here. After 85 we are at 15. So after 75 we are at 15, 85 and 85. After that we are at 15. Now 15 mod 10 is 5, but fifth index there is 75. I find next location, sixth index, again there was 85. So I got the next index 7. So after 85 the fifth index element is stored at the 7th. So we are giving here chain to the 7. So this is called as a linear probing with chaining without replacement. This is called as, since we are giving here a chain. Now the next concept we will see here again in the linear probing, that is linear probing with chaining with replacement. So if you look at this example here, in this example these are the keys I want to insert: 11, 101, 88, 18, 48, 370, 19. So first of all I inserted 11, then I inserted 101. So 101 we have second index, but index is actually 1, so we are giving here second index, because after 11, 101 is at the second index. Next is 31. So basically here this is 3. It's not a 31, it is basically a 3. So this 3 is at right index. Next is 70. So we have 70, basically it's supposed to be at the 0th index, but we don't have a space here, so we whatever the next location we find here, so we inserted 70. So like that way basically we have given here the probes, and we have added the chains for this particular things, right? Now look at here, very interesting, one more thing, because you already saw this type of example. Now after 18 there is a 48. Now 48 mod 10 is 8, but at index there was already 88. So what I'll do, 8 plus 1 9, 9 mod 10 is 9. So 9th index if I try to insert, already there was a 18. So again what I'll do, 8 plus 2, that is 10. 10 mod 10 is 0. So at 0th index there was nothing, so I've inserted here 48. Since after 18 the next element of index 8 was 48, and which is at index 0. So we are marking here the chain at 0. Right? Now this was actually linear probing with chaining without replacement. We have already seen in previous slide. Now here there is one more type, that is called linear probing with chaining with replacement. So what we'll be doing here, so we'll go inserting one by one. So first of all 11. So 11 mod 10 is 1. So we have inserted 11 at first index. Next 101 mod 10 is 1. But at first index there was 11, so I will do 1 plus 1 2 mod 10 is 2. So second index the slot was available, I'll add here 101, and the chain will be given here as 2. Next is 88. So 88 mod 10 is here at the 8th index, we'll add 88. Next is 18. So 18 mod 10 will be 8, but we'll add one more, and the 18 will get inserted at the 9th location. So we are giving here chain as 9. Next 48. So 48 mod 10 is 8, but 8 there is a collision. Again at 9 there is a collision, so 9 plus 1 10. We are inserting 48 at the 0th location and giving here the basically chain as 0. After that there is a 3. So 3 mod 10 is 3, so 3 will get inserted at this particular location. Next is 70. Now look at here, 70 mod 10 is 0, but at 0th place there was a 48, and 48 not supposed to be with index 0, right? So who deserves the 0th index? 70 deserves the 0th index. So instead of 48 we'll enter here 70, and for 48 we'll find out the next location. So after that I find the next location empty is 4 by doing a linear probing and rehashing. So I get here 4. So now here 18, previously the chain was given to 0, but since 48 is replaced at 4th location, now chain given here will be a 4. Very important point. Okay. After that there is a 19. So 19 mod 10 is 9. So at 9th index if I want to replace here with 19, there was already 18, but 18 is supposed to be with index 8, and who deserves the index 9? 19. So 19 will come here. For 18 we'll find out next empty slot. So for 18 the next empty slot here we get is 5. So at 5 we'll put 18, and since after 18 there was a 48 with chain 4, so we'll copy this value as it is over here. Now after this 19 we are replacing here with the no chain, because it is only one element belongs to index 9, that is -1. But now here 18 ka index got changed, so here I need to replace the 18 ka index. Instead of 9 here we replace it by 5. So this concept is called as linear probing. We are giving chaining, so with chaining and with replacement, because if the element belongs to a particular index, and at that place if there was certain element which is not belongs to that index, we are replacing that element which is actual deserving element. So this is another type of technique comes under the probing, linear probing with chaining with replacement. So we have to implement these two algorithms in C programming. We can use a two-dimensional array for implementing these two algorithms, that is collision handling using linear probing with chaining without replacement, and collision handling with linear probing with chaining with replacement. So in next video we will see the two different techniques which are emanating from the open addressing, that is the quadratic probing, and the next one is the rehashing technique. Thank you for watching the video.